So for these Ferris wheel problems, a Ferris wheel loads all the people, and when the ride starts, you are seated somewhere around here. The wheel turns counterclockwise, so you're there. Counterclockwise, you'll be going up first, based off of that spot. Let t be the number of seconds since the Ferris wheel started. It takes 21 seconds from that spot to get to 43 feet. It's going to take 5 minutes to go all the way around. That means that's the period. 5 minutes all the way around, that's period. Now, reading back a couple of seconds, let t be the number of seconds. That's 5 minutes. That means that's no good. So we got to change 5 minutes into seconds. We do that by multiplying by 60. 300 seconds. That's the period. We're going to need that. The diameter of the wheel is 78 feet, and at the lowest point, you find yourself 4 feet off the ground. So the lowest point, that's at 4. The diameter is 78. That means the highest point is 78 above 4. 78 above 4 would be 82. Which means the middle height, you can just add the radius onto the 4. So if the diameter is 78, that means the radius is 39. 39 plus 4. I'm going to mark that real quick. But that needs to be 39. 39 plus 4 is 43. And then that should be another 39 to get up to 82, just to make sure your math is right. This should also be 39, which it is. So, notice we've got our 3 lines, just like we did with similar problems to this. You got your 3 lines. That's how you start your graph. This one's at 4, this one's at 43, this one's at 82. So we got our maximums, our minimums. We even know our amplitude in there. So now we need to go back to this statement that we skipped over. It takes 21 seconds. So we're starting here. And after 21 seconds, we're now at 43 feet. 43 feet is significant because it's that number we wrote right there. It's the midline. So we're at 43 feet after 21 seconds. There's our starting point. That's what we're going to use to start our graph. Now, which direction is this Ferris wheel going after that? After we hit that 43, what's our next move? Are we going up or are we going down in the Ferris wheel? So we're starting at the middle, going up. What trig function starts at the middle, going up? Sine. So that's a sine graph. That is one period of sine we just drew out. So when we go to write this, when we write the sinusoidal equation, remember that could mean sine or cosine, but this, based off the info, we're using a sine equation. The number that goes in front of your trig function is called amplitude. What is the amplitude? 39. 39. It comes from the radius. That's how much you go up and down from the midline. And the rest of our equation is going to look like this. We got to fill in a B, that's our period changer. We need to fill in our phase shift that goes with the X, and our vertical shift that goes at the back. So B is the period changer. Period changer, the formula for that thing is 2 pi over B equals period. Period equals 2 pi over B. The period's 300. So the period equals 2 pi over B. So to solve for B, we get 2 pi divided by 300. B is 2 pi divided by 300. You could have reduced that, but you don't have to. Phase shift. This thing shifted. We did not start at time equals 0. What time do we start this? 21 seconds. And it's to the right 21 seconds, so that's x minus 21 for our shift, phase shift. And then we got a vertical shift, also known as the midline, which is 43. So there's our sinusoidal equation. We probably should say y equals or something like that. There's our equation. You could graph this. It'll graph something very much like the sketch here, but it's going to keep going. We want to know how high we're going to be on the Ferris wheel after 8 minutes. Now, that's not 8 minutes from the time that, it's 8 minutes from the time the ride started, not 8 minutes from whatever this dot was. It's just 8 minutes from the time it started. So we've got to plug in whatever 8 minutes is in seconds, because remember this function is seconds. So 8 minutes to seconds, 6 times 8 is 48, so that's 480 seconds. That's what we're plugging into this equation. You could graph it and plug it into your graph, or you could just plug it in. You don't have to make the graph for this. You could just plug in 480 seconds. Right there. That's just our x value. Now, when you plug it in, your calculator has to be in the right settings. Is this degrees or radians, and how can you tell? Radians, because there's a pi, or 2 pi over b, that made us be radians. So 2 pi over b, that's radians. This needs to be radians. So on your calculator, we need radians. Shift, setup, check your angle down here, make sure it says radians. Then we can type in the equation. 39 sine, we're going to need some parentheses, 2 pi over 2 pi over 300. X, what are we plugging in for x? 480 minus 21 plus 43 at the end. And if you type it in exactly as we drew it, as we wrote it, we're solid. We're in radians. We're going to be at 35.7 feet.
What? No, I know. I put that.